Hey Southampton, welcome back. It's Mr. Pritchard again. It's Saturday morning. Let's see, 9 o'clock. It's the 28th of March. I haven't seen my students in 2 weeks. Hey, it just stopped raining. We had a lot of rain last night. I heard a lot of rain this morning when I was up taking my shower. Still a little wet from the shower, sorry. Anyway, thought maybe it would be time to look at some of the systems that are going on in science here in nature. Speaking of systems, the water cycle is a system. So check it out right now. If you can look, you can see that everything's all wet. Whoa, oh, there's Boo Boo, that's the cat. Check out this spot right here. This is an issue. Here we got a problem. Looks like all the water that's been landing in my backyard and on that farm field over there has been running down this hill, and it's been coming and joining together to get to this spot where there's like a little dam. Excuse me, the cat wants to get in. That's where her food is. So yesterday was a really pretty day. I was outside all day working on different things in the yard and shooting a video about alternate versus opposite branches on trees. Anyway, today's a different day and it's very rainy out. You can really see the water cycle happening. If you look out across here, check out how foggy it is. What's basically happening is the air is so cold that the moisture that's in the air, now that's the evaporated water that's in the air, the water vapor, is condensing. Basically what's happening is the particles are moving really, really fast because they're gaseous. And the water particles are moving really, really fast because there's a lot of heat in the air. But right now it's getting a little bit cooler and it's cold enough that the water particles that are moving pretty fast are moving slow enough that they stick together and they make a big droplet. And so that's what when I say big droplet, I mean it's pretty tiny, but when you put about a bazillion of them together, it looks like fog and it looks like clouds. And so that's what's happening up there where it's really cold up there in the upper atmosphere, you get a bunch of fog. So as it condenses, that's when it gets colder and gets stuck together and forms a droplet. It gets heavy and then it falls down. Now, falling down, that we call precipitation, as you're well aware, I'm sure. And rain is just one of the forms of precipitation. There's also snow and sleet and hail and things like that. Well, once it hits the ground, it starts to collect. Like you got puddles out there on that farm field, right? And it runs downhill. Like in my backyard. Oh, there's my 18-year-old dog. Hi, Daisy. So the water runs downhill and it kind of tries to go as far as it can. And I got a problem because I've got this spot where the water's collecting. So something has to be done about that. So the water cycle, it can start anywhere. It might start when it's raining. So here we go. We got the rain. It just fell down. It's hit the ground. It's running off. We already talked about running off. And now as the temperature will get warmer in the next couple days, all this water will start to evaporate and go back up into the sky. When it gets up into the sky, it'll get cold way up there and it'll start to condense. Those water particles will slow down enough that they can stick together, become little droplets. They turn into clouds. If they get big enough and heavy enough, they'll fall straight to the ground in the form of precipitation again. Now that's not the whole story because some of this water is not gonna dry up. Some of this water is gonna infiltrate the ground and it's gonna percolate into the soil and it's going to collect in underground reservoirs that we call the aquifer. And thankfully we have an aquifer because that's how I get the water for my house. I actually have a hole that we've drilled into the ground. It's got a well and we have a pump that's down in the ground that pumps the water back up and then we use it in our house. So if the water didn't get into the ground, there would be no water for the aquifer. I wouldn't have any water for my house. And it also is much cleaner when it goes into the ground than if it just runs off. You know, when it runs off, you can see that it can pick up all kinds of dirt and crud and stuff along the way into the bay because that's where all this water is heading, into the Chesapeake Bay. And then you end up with a pretty polluted bay. So now Mr. Pritchard's got this driveway and the driveway is made of asphalt. Asphalt doesn't allow water to go in. I'm robbing the soil of the ability to absorb the water. It's running off. That's why we got that big old stream thing going on down down at the road down there. There's a lot of water. That guy is gonna go through, he's splashing through the water as he's driving, and that's water that came off of my driveway. So what do you do to try and reduce that? You know, the driveway is not the only place that's waterproof. I've also got the roof on my house and the roof on my shed. The shed is pretty big. That's a pretty big watershed. So when I built it, I thought, I don't know, man, I don't think I want to keep all that water from going into the ground. I mean, that's a lot of surface that is impervious that won't allow water to percolate into the soil. So what I did was I built a rain barrel system for my shed. So if I come over here, you can see the gutter that runs along the front of the shed, and then it comes up here and it makes a turn. And then if I go inside here, you can see that the rain spout continues over here, right? And look, it collects it from the other side too. So here's the other side of the shed, right? And the downspout, I mean the rain gutter there collects water, and it all goes into these two downspouts that are dripping into this big rain barrel system. This is a tandem system. It's a little bit more complicated than the ones that we make at school. And if you look down here, it's kind of hard to see, but under here, the two rain barrels are hooked together. And then there's a hose bib right there so that you can hook a hose up to it and access the water. Or if you really want to get the water out fast, you can open up this 1.5 inch ball valve, and the water will run out this pipe and shoot out across the ground over here. And sometimes I use that when I'm rinsing stuff or rinsing barrels, or if I need to have a lot of water really fast, or if I just want to drain my rain barrels, or maybe it's just really dry out and I don't mind having water run across the ground because since it's so dry, it'll suck up that water and go right down into the ground, and then we're letting the water percolate into the soil like we wanted it to. So that's one of the systems, that's the water cycle, and you can interrupt the system and you can do something to change it a little bit, because what I'm really trying to do is I'm trying to reduce the amount of runoff that's going into the Chesapeake Bay. And so by sequestering the water or stopping the water in a rain barrel and then letting it out when it's hot and dry later, then I can let the water soak into the ground. Right now, if that water was running across the ground, it's all saturated right now. The ground's so wet, it won't absorb the water. So if I hold on to it and I let it out later, well, now it's gonna soak into the ground, and that's a whole lot better for the Chesapeake Bay. Thanks for being with us today. And we'll continue with our little science lessons because I'm kind of enjoying this and I feel like I'm with my students again.